Hey there, Dangar here. Today we're going to look at some ignition diagnosis. So this is the sort of thing you might go through if you're getting no spark at all, or you're getting some particular sort of performance problems that might be related to a poor spark or whatever. This motor does actually have spark at the moment, but it does have a bit of a weird kind of misfire at low revs. So I want to do this video anyway. In some ways it's a good motor to do on, just to see whether perhaps this is the cause of the problem I'm experiencing. So the first thing I do here actually is check the battery and the connections here. This motor's cranking quite slowly. It doesn't start with any sort of strength or confidence. The battery system's sort of slightly independent of the ignition system, but having said that, the battery really is the heart of the whole electrical system. So I'm going to have a look at that system first, see if we can get this cranking more strongly, and then after that we'll start looking at the ignition itself.
So first thing I'm going to do before I begin all of this is actually just hook up a little start button so I can sit back here and crank the motor over. I'm going to need to be able to do that for all steps of this process. So it's pretty straightforward. So this is the relay or the solenoid for starting the motor. So the main lead from the battery comes into here, and then when it switches on it passes current through here straight to the to here, to the positive of the starter motor. And what activates that is when power passes through this part of the circuit. So this is a ground, and then this one, if I just pop this off and do this one-handed, here we go. So when power comes through here, or current flows through here, it activates the relay, and then current's allowed to flow through here. So all I really need to do is supply power to this. So I'm just going to get one part of my alligator clip, there we go, get that on. And then the other clip I just need to put to anywhere where there's power. And the obvious place for that is just where this power comes in. So I'll just clamp it on here. Alright. And then these just go to a switch. This is the dodgiest start switch I've ever made. I just made it 5 minutes ago. This is actually a limit switch for some sort of, like a trolley or something, just to let it know when it's reaches the top. But it'll do, it's all I had. So now, if I hit that, it'll crank over. So I'll just put this camera back on the stand and we'll start looking at the battery.
So I'll give you a demo of what it's doing. So if I hit this button now, so just to make a liar out of me, that started quite strongly. I'm actually starting to suspect, and I always did in some ways, that I put a new push button start in front. So I'm thinking it's actually perhaps the current flowing into the relay, the current that actually activates it, that's intermittent, not the relay or solenoid or the battery leads themselves. So I think we can consider that good. It's certainly good for our purposes now, and get straight on to test ignition, which is what this video is about anyway. So I'll look into the other problem later. We'll push on. So a good way to kind of test this system end to end is to use something like this, which is a, can you see that? Yeah, there we go. Which is a spark gap measuring tool. So essentially what happens is you can wind this part out and increase the gap between here, and a good spark should be able to jump a certain gap. There's measurements inside here, probably very hard to see on camera, but take my word for it. And the manual says that this should be able to, this ignition system should be able to jump a 9mm gap. So have a look what your motor is, set the tool to that, and you then should be able to take your ignition lead off the spark plug, put it onto here, attach this to a ground, and when you crank the motor you should see a spark. If you don't, there's not a high enough voltage to jump that 9mm gap. So we'll give that a go and I'll show you what it looks like.
So to do this, I'm just going to pop this lead from the coil off the spark plug and hook it up to our tester. Sorry, a little bit tricky one-handed, but we'll get there. Actually, now I think about it, hang on. Spark plugs have two different ends on them. This motor, these leads,
run without the ends. Make sure you don't lose that bit. Then all I have to do is put this onto a ground somewhere, which is anywhere in the body of the motor that's not painted. Now I'll bring the camera in closer and we'll hit that starter button and we'll see if we can see a spark. So as you can see, that was jumping the gap, which is great. But you were starting to see that slow crank ignition problem I was talking about before, which goes back to perhaps either a weak battery or getting a voltage drop somewhere along the line of connection. So for cleaning, I'm just using a combination of a little stainless steel brush and some wet and dry sandpaper. So they're all cleaned up now. I'm going to give it a crank. I'll try a different spark plug this time, so I'll start testing other coils. Then I'll give it a crank and see if it's improved now. I'll clean those up a little bit. You want to see how the sun shines into my armpits? So what we've learned so far is that all the coils are producing enough voltage for the spark to jump the specified gap, this 9mm gap. So that's good. It doesn't tell us whether the spark plugs are working properly. It doesn't tell us whether the pulse coil is firing the spark consistently at the right time. But I am going to go through testing, perhaps if we were getting spark, what you'd do next. So to measure the resistance in these high tension leads, I'm just going to unscrew the end here. So these leads, I don't know if you can see in there, they actually have a threaded end. So that thread screw just goes straight inside the lead here. Now we're going to test the resistance of this using a multimeter. So to do this test, I'm going to use a digital multimeter. I'm going to set it to ohms. So 0L is like infinite resistance, so it's saying there's just it's an open circuit. And I've got it set to the ohms plug here rather than the amperage plugs for testing current and a copper. So all I want to do here is grab this lead, put one end inside and one on that thread we saw before. So I'm getting 4 kilo ohms on that, and the specification is 3.5 to 4.7. So this connector is within specification. So I'm going to go through now and test the resistance of all of these in the exact same way. I'm just touching one to the metal inside here. See if I can show you here. You can see that. One to the metal here, and I'll start to get a reading. I'm getting, what are we, 4.3. Hope, let me have a look. Yep, 4.3, which, look, it's at the high end. 4.7's the highest resistance we'd consider in spec, but it is within spec. So I'll go and do that for all the others and we'll see if we've got a problem there. So what I'm going to do now is take one of the coils off, and we're going to measure the resistance of the primary coil and the secondary coil. I'll take you through a bit of the theory of what these coils do and how ignition coils work, but we're running out of daylight, so I'll do that as a video in the workshop, and I'll splice it into this. You'll probably see it now.
So I won't bore you too long with this, but I think it's worth just having a quick look at the overview sort of diagram of the ignition system before we keep going, just so you can sort of pitch how it all hangs together a little bit more easily. Now I was going to draw something up, but the diagram in the manual is actually pretty good. So what we've got here is essentially the sort of the flywheel, and there's these two coils under the flywheel. There's the pulsar coil, that triggers when the spark should fire, and this charge coil that charges the capacitor inside the CDI unit, which is this one here. So when it gets triggered, a current flows through the primary coil of one of these two coils. So these are sort of what they consider coil packs. Each one drives 2 spark plugs. So the top coil pack supplies the spark for, or the current for, spark plugs 2 and 3, and the bottom one supplies the current for cylinders 1 and 4, which is exactly how they go up in pairs, as you'll see if you've got the head off anytime. So what happens is this the electricity stored in the capacitor comes through, and it flows through this primary coil in one of these, and that induces a current in this secondary coil that's a much higher voltage here. So it's like a step-up sort of transformer, and it's that really high current that lets you get the spark in these spark plugs. So that really is, you know, the parts you've got. This diagram here also just shows you the ignition switch, which is quite an interesting switch. It's got sort of an off position, on plus the starter motor going. But really, it's this part here and the coils here that are the heart of this CDI unit. So anyway, just thought it'd be good to show you that, and then we'll just get back to it.
So, to get these ignition coils out, they have 2 leads that go in under this cover. This cover is just a, literally just a cover for the all the wiring that's under here. The CDI unit's actually around the other side. So I'll just take these screws off.
Okay, so what we got here is 2 orange leads from these coils, which is the positive, and then these grounds all go to a screw here. So I'm just going to disconnect the orange leads here, and then test the resistance between this earth point and the orange lead here, and this is testing the primary coil. So this is the first coil that gets the low voltage here, which induces the high voltage through the secondary coil. So I'll take this off and we'll pop it on the multimeter.
So here you can see, hopefully under my arm, we're getting 0.2 of an ohm. So the spec for this actually says 0.08 to 0.11. So it's actually slightly out of spec. That can be a little bit of surface, contamination that's causing this. So it's worth cleaning these up while I've got them out. But that's the test we're looking at to test the resistance of the primary coil. Once again, same as we did with the high tension lead with the connector, but different specification, different set of points to test the resistance across.
Now, testing the secondary coil on one of these is really simple because these coils serve 2 spark plugs, and all you need to do is take a single coil. So in this case, we've got cylinders 2 and 3. So it's 2 leads on the one coil, and then all we need to do is test the resistance from one high tension lead to the other. These coils can't fire a single spark plug, single spark plug or a single cylinder. They can only fire 2 cylinders at the same time, and so it's what's called a waste spark system. So one of those cylinders is at the top of its compression stroke, it's ready to fire. The other is at the top of its exhaust stroke, so the spark is actually just wasted. It's just firing when there's no flammable charge there to actually ignite. But it makes it nice and simple. It means that the CDI is just firing them in pairs, 2 coils instead of 4 coils, and you test the resistance across here. Interesting sort of effect of that is that the spark jumps from the anode to the cathode on one and the cathode to the anode on the other, I think it is. So it jumps a different way across the spark plug, but obviously it doesn't really matter, it all still just ignites the fuel.
So I'll just show you here. The spec here is 3.5 to 4.7 kilo ohms. A lot more windings in this secondary coil. And you're testing across this coil like it says. So here you can sort of see the specs for the 2 different
two different coil windings.
So what do we know now? What we know is that our, well, we knew from the start we were getting good spark, so that's pretend we weren't. But we do know that the primary and the secondary windings in the coils have the correct resistance, they're within specification. So that's a good start for the actual coils. Now, the coils need to be supplied with a proper voltage to the primary coil in order for this spark to come out from the secondary coil. And that's delivered by the CDI unit, which is a capacitive discharge ignition. What that means is that there's a charge coil under the flywheel that charges up a capacitor inside the CDI unit, and when a pulsar coil, which indicates a bit of like a crankshaft position sensor, that kind of idea, indicates to the CDI unit that the flywheel or the crankshaft's in the correct position, it sends a little electrical pulse to the CDI unit that says to actually drop the voltage on that coil, because it's actually the drop that causes it to induce a high voltage in the other coil. But it's essentially, don't worry too much about that. The point is that it's the signal that tells the CDI unit when to send the voltage that will cause the spark plug to fire. So, just going to pop the cover off this flywheel. These Yamahas are nice and simple in that they don't have any screws holding that cover on. And what I'll show you here, so this coil is the pulsar coil that sends the signal to the CDI unit to say when to fire. But it needs to be gapped, so I'll just quickly bring the camera in, I'll show you here. So you can see here, this is the coil, two wires coming out, and there's a gap between the flywheel and the coil here. Now if I turn this flywheel, let me grab a shifter or something. So what you'll see, as the flywheel comes around, there's little protrusions in correct positions. And so those little protrusions that tell that, there we go, there's one coming just now, hope you can see it, that induce a current. So you can see there, it's a little protrusion on the flywheel, and that's what induces the current inside that coil. And the gap between that is really important. So what you do is you put a feeler gauge in there. So I'm going to grab a feeler gauge and we'll see what the spec is. So what we can see here is you pop your feeler gauge between the coil and that protrusion, and the gap should be between 0.5 mm and 1 mm. So I think our gap's actually a little bit too big. So I'm going to grab some feeler gauges and we'll see what this one's actually sitting at the moment. So this feeler gauge is actually the largest one in this set, and it's a 0.88. And you know, it's got just a bit of resistance, which is really what you're looking for with a feeler gauge. So it's probably fair to say this is within spec. It's definitely on the high side. I'd be inclined to, I mean, you don't want it too close either. Look, it's in spec, so I think we can consider that good. Alright, fresh day, fresh charge. What I'm going to do here is just take this clip, which is the connector for the pulsar coil. So now we're going to start testing some of the voltages coming out of these. And to do that, I'm going to use a DVA, which is a direct voltage adapter, onto a multimeter. So I'll show you that. I've actually got another video on building one of these, so I'll put a link to that. And we're going to use that for testing the voltage coming out of all these coils. So this plug has very slim blades that go into it. So I've just made a couple of bits of wire. I'm just going to push those wires folded over like that, just into where the blades go. And hopefully that will give me something I can clip my multimeter onto and get a good reading out of this. Now I've just got a few alligator clips on these multimeter leads. Just find somewhere to prop those so they don't put too much tension on those wires, because I think they'll pull out pretty easily.
So what I've got here is the direct voltage adapter I made in that other video, and now I'm just going to plug these into my DC volts on the multimeter and then see what voltage we've got coming out of this pulsar coil when I crank the motor. So here I've got my multimeter on voltage. This doesn't have a DC AC range, but you want it on DC because this converts from AC to DC. That's one of the things the adapter does. And then I've just got my remote start switch here I'm going to use. I've also got the ignition off, so we'll just crank this without it starting and see what voltage reading we get out of that pulsar coil. So it's showing about 5, and so here is the spec for the pulsar coil. It's saying should be 6.3 unloaded and 3.5 loaded. So look, it's in between. It was unloaded cranking. So, you know, I'm pretty happy with that in the scheme of things. If it was wildly off, we'd know we had a problem. Okay, so that's how we test the voltage coming out of that pulsar coil. So now I'm just going to pull these wires out. We'll clip that back together. So the next one I'm going to check is this, the blue and brown one from here, which is the charge coil. So this is where the charge goes into the capacitor that gets triggered to be discharged by the pulsar coil. So this one's actually got the male plugs going to the coil, so I'm just going to see if I can get these alligator clips on there, and we'll see what that's putting out. So this charge coil is supposed to put out 144 volts cranking unloaded and 137 cranking loaded. Then up to about 170 at 1500 RPM loaded. So let's give it a go. So that's reading probably actually a little bit higher, but close to what you'd expect at 1500 RPM loaded, so I'm going to consider that healthy for now. But that's the test for that coil. Now we've got just the output on the CDI unit to go. So we know the CDI is getting voltage in, correct voltage in to charge the capacitor. We know that it's getting the correct signal to discharge the capacitor. Now we just need to see what comes out when we do discharge that capacitor. And that's what these voltages are here. So I'm going to unplug these and have a look whether we might just use a probe, and then we want to go to the earth, which is here. So I'll just rig that up and we'll see what values we get from this. So when I unplug this, this actually broke. This is the sort of the female part of the connector. It's actually snapped off here and the female part stayed over this part. So curious to know whether that was not healthy in the first place. May have been a part of my initial problem I was having, particularly not getting good spark at low revs, and maybe as the revs jumped up the voltage was enough to jump this bad connection. So I'm just quickly going to dodge this up a bit. I'll probably expand that male section, put this in and crimp it down. So I'll just quickly fix that. So I've got this hooked up now with an earth and just onto the first coil, the orange lead, which is the positive lead into the coil. And we'll see what reading we get off that. Should probably go turn the ignition on. So when you switch the ignition off in an engine, you're actually earthing this coil so it the capacitor so it can't charge in the CDI. And that's why with the ignition off you won't get any sort of reading through here. So you need the ignition on to do this test. So that reading was quite low. That was 50 volts.
It got up there quite slowly too, and it's supposed to be between 126 and 150 while it's cranking, and about 150, 116 while it's running. But I think that's actually a problem with the direct voltage adapter. I believe that first resistor in line is meaning there's sort of a duty cycle to this current. So with the other voltages we were getting, you're just running quite a high frequency AC current, you're converting to DC. But in this case, it's only firing whenever it needs to fire a spark. And I think that what the effect of having that resistor in line is that the instrument's measuring it too slowly. And so you're sort of ending up with an average of when there is current and when there isn't current. So I'm going to bypass that resistor and see if we get a different result. If we do, I'll update that video on making a DVA adapter, and we'll a bit of an experiment, see what happens. So I'll do that now. I might actually even put a switch that allows you to bypass or have it in as a bit of an extra feature on that adapter, but I'll just experiment with shorting it out now and we'll see how we go. Okay, so that's with a little jumper wire now, just shorting out and bypassing that resistor, so we'll see what reading we get this time. So as you can see here with the resistor bypass, it's gone straight up instantly to 184 volts, so it was definitely a bit of a duty cycle issue. I guess we both learned something about making DVA meters. I do believe there is a place where the resistor has its benefits. A lot of the designs I saw for DVA meters had that resistor in line. So what I'm going to do is break this out to a switch on the outside of the box so that I can either bypass that resistor or leave it in line. What it turns out is you definitely don't want that resistor when you're testing CDI ignition. Now this is actually above spec. You can see here, it's 285. So I'll just grab the manual and have a look what it's supposed to be. Alright, so we might be okay here. So what it says in the manual is measure the CDI unit output, peak voltage, which we just did. If it's below specification, measure the charge coil and the pulsar coil, which we've done both of those already as well. If both of those are above spec, then your CDI is bad. So really what it's saying is, if your CDI current's bad, make sure your pulsar coil is good and your charge coil is good. If both those are good, your CDI is bad. If either of those is bad, it might not be your CDI, it might be caused by the other two. So it doesn't seem to be any huge problem with it being above the required voltage. I guess it just means you get a stronger spark. So this ignition's checking out okay. It did have that little problem at idle, and we did notice that broken connector going to one of the positive side of one of the coils. So I'm going to take it for a test drive. That may have actually been the problem all along. It may have actually just been broken inside its connector. So I think this motor's looking in pretty good health. So thanks for watching. I hope you can use this information to help you diagnose any ignition problems you might be having with your outboard. This is a pretty common setup, this sort of CDI ignition. I think this is pretty common in motorbikes as well, so you might be able to use this information if you're diagnosing a motorbike as well. You really do need to make one of these little direct voltage adapters in order to do all these complete tests, and then just use a normal multimeter. So I'll put a link in the description to the little video on making that. I'll also do a second video on revisiting it and putting that little bypass switch in. And that should give you all the information you need to try and figure out what's wrong with your ignition should you have some sort of no spark situation. So thanks again. Please subscribe if you want to see more videos like this, and I'll catch you next time. See ya.